All right, so this week, for week 6, so I had questions 1, 2, and 3. We can start with those.
Right.
1 and 3 were just conceptual questions, and they were pretty self-explanatory. So, I mean, if you guys have anything to add, you can let me know. So, examples of a situation where there's force and displacement, but there's no work. So, if there's an object that's moving across a frictionless surface, like I was thinking like air hockey, you know, that puck just kind of floats and it moves, but there's no work being done. Or if the net force is 0, so there's like the force of gravity going down and the force of friction, I'm sorry, the normal force up. If it's anyway, if the net force is 0, I guess, then, sorry, I lost it. Then there's no work. And then the other one I said was, like, if you're moving it at an angle of 90 degrees, if you're moving up and over at an angle of 90 degrees, then cosine of 90 is 0, and it would just imply that there's 0 work because you're multiplying it by 0. I don't know if you guys want to add anything or change anything about that.
No, it looks good.
Okay.
Yep. Looks good to me as well.
Okay, cool. Number 2, I started a little bit with part B, so maybe you guys can help me. But it's basically asking to find the different works for the different forces, and then to add them all together. And so for A, the work done by friction, I did the work of friction is gravity times mu times the displacement times cosine of theta. And then I said that theta was 120 degrees because it's going to be a negative work because it's going in the other direction. And so I just multiplied them together, 9.8 times 0.1 times 30 meters, and then cosine of 120, and I got negative 14.7 joules. Does that look okay to you guys? Because I wanted to make sure that that was indeed supposed to be negative.
One second. Sorry. I was trying to I just woke up from a nap.
You're fine.
Napping at this time of day. I got something different, but I'm trying to figure out what I did differently.
Okay.
I don't know. You probably did it right. I can't even.
Well, do you know what you did? Or Mason, did you do this problem?
Yeah, I'm looking at it. That's weird.
I can't tell what I did.
Huh.
Let's go with yours.
Okay. Because the only thing I wasn't really sure about was if you were to use cosine of 120. And I was kind of looking at some of the examples, and I noticed that, like, if you're pushing it on a horizontal surface with friction, like when you're pushing it in the one direction, you have cosine of 0, but then when you're, like, considering the work of friction, it's cosine of 180. So I figured you were using the opposite, like, since you're going the other direction. So I figured that the same, but I wasn't positive.
If you do cosine 60, you get the same answer anyways.
Well, right, because cosine of 60 is positive, and then cosine of 120 is negative. Yeah. And so that's where I got that negative from. So I assume that's correct, but then I don't know. And then the work from gravity for part C, I did mass times gravity times the displacement times cosine of 60, and I got 13,233 joules. But then for the work of the rope going down, I guess I just got confused because they're lowering it, and so I didn't know if it was like a tension force from the rope.
It should be tension.
Right? And so that's what I thought too. I just was kind of confused. Like, I just didn't really know how to, what that formula would be then to solve for the work.
Let's see. Where's my
work of the rope?
We don't know that.
Mass times gravity. Yeah. Mass times gravity. Minus.
Because the tension formula is mass times gravity plus mass times acceleration, right?
Right. And I think it says on there that they're lowering them at a constant speed. So that was the other thing.
Yeah.
Is that
Mhm.
if there's a constant speed, it makes acceleration 0. So would it just be mass times gravity?
Yeah.
But then I feel like that would make it the same as the work due to gravity, because it would just be mass times gravity times displacement times
But I
cosine.
think there has to be something to do with the angle as well.
Well, right, the 60 degrees, yeah. So that's what I didn't know. But then I also wondered if with the work due to gravity, if that is supposed to be cosine 60 or if it's supposed to be cosine 90. Because the force of gravity goes straight down. It doesn't go perpendicular to the slope. Does that make sense?
Yeah. I'm just searching through the book really quick. I feel like I saw a formula. I feel like there's a lot of different formulas.
There are so many different formulas to apply in so many different ways.
Yeah. So I feel like I saw one that I wanted.
There's a practice problem in the video that kind of explained to me how to get those forces. But of course, it was working on a flat surface, horizontal surface, and so it didn't have a slope. Or yeah, it wasn't it didn't have any degrees. So it had gravity as cosine of 90. I guess gravity's not going to change. So that would kind of maybe change that.
I don't know. I mean, because I know it's gonna be mass times gravity.
This is the formula that I used.
Friction cosine theta. Minus friction.
Minus the. How'd you do the mu sign?
I don't know.
Equations. You have to insert an equation.
Oh.
Here, I'll help you out.
The air just gets wrecked, bro. Every single time. It's kind of annoying.
There we go.
This one's new.
Awesome.
There it is.
Perfect. Mu cosine.
See, this is what I did, but I can't find the equation again.
Huh.
Maybe I got it on Google. There's a few I had to look on Google to find out how to do.
Yeah. Okay, so mass times gravity times displacement. Where did the sign come from? That's what confuses me, I guess.
I don't remember. It's one of the formulas I saw.
Okay. Yeah, that's fine. Okay. Yeah, the only other thing that I could think to do that I probably would have done before the meeting is that I might have made this for gravity up here, cosine of 90, which would make the work due to gravity 0 joules. And then I probably would have put this equation up there, up with this one for the work of the rope. And then done it that way. But what answer did you guys get with the equation you just wrote up there, Mason?
Give me a second. My computer's lagging.
The equation I found was even a little different than that. It also, after that, it had times distance cosine 180. I don't know. My equation might have been a little overkill.
Like you found everything in that formula.
Yeah.
I got negative 2.16 times 10 to the 4th joule. but
Okay.
heaven knows.
I know, it's so complicated because I feel like I know what I'm doing and then I don't.
Yeah. 90
Time,
times.
you
90.
said 60 sine minus mu times cosine.
I got a negative 1,145.75.
Huh.
That's 719.
I think you have more muscle than most people.
I don't know.
Yeah, I don't either.
That sounds good to me.
You got to.
What did you say that you had gotten, Mason? I got something like 21,592.
Sounds like what I got.
Okay.
And then I rounded it to 3 sig figs.
That's what I got.
Hmm. That's so strange. We got the same answer.
Huh.
Oh. Yeah, I'm really confused how we got a different format but same answer, but hey, that's all right.
Yeah. Okay, so we'll leave that in there. Just like that. And then, so for the work due to gravity, should this be cosine of 60 or of 90? Oh, shoot.
Of gravity.
Gravity.
Because if it's 90, then the answer would be 0. Which, I mean, I guess gravity's not really going to do any work on it. I mean, well, actually.
9 times 10 to the 4.
Yeah, it is.
So I used the total work equals the sum of the other work. Wait. Oh, wait, never mind. That's for D?
That's for D, yeah.
Yeah, my bad.
So I'll put this one in there. 1145.75.
It's mass, gravity, distance times sine of, or cosine of
Gravity,
60.
distance, cosine
Cosine of
theta.
60?
Distance, cosine theta. Here, I'm checking yours compared to what I used. MGD cosine theta. But I also had a sine of 60 in there. Hold
You had
on.
a sine of 60 in there too?
Yeah, I did sine.
Yeah.
I didn't do cosine, though.
Yeah.
Both did sine instead of cosine?
I did sine as 60 instead of cosine as 60 in your as on the formula there.
I got cosine video, but that could be wrong. I don't know. I know enough to let a point, you know what I mean?
I don't either. What's happening? So Mason, what'd you get for your answer?
For the answer for C, I got that.
And you just changed this to sine instead of cosine?
Yeah.
I got the same thing. 2.2915, yep.
And just get rid of this. And then change this one in here. And then I gotta get a sum.
You didn't work out working anywhere else.
So for the total, 24,
46.08.
0.08, yeah. And that's what I got.
Me too.
Cool.
Okay. The only thing I'm gonna do is just erase Mason, you want to erase that number since I put it back into the formula there?
Which one?
I think I can. Where your cursor was. Oh, yeah. Oh, no, I just did it. Never mind. Okay. So that's number 2. Number 3 says work done to a system puts energy into it, and work done by a system removes energy from it. Give an example of each. So I said like pushing a lawnmower at a constant speed puts the kinetic energy into the system. So like if you're pushing a lawnmower in a system and the system is receiving energy or its energy is being put in it. And then I said if a swimmer pushes off the side of the wall when swimming, from the swimmer. By the system, the swimmer at least is what I said for that. Any questions about that one?
No, looks good.
Sounds good to me.
Sounds good. Numbers 4 and 5 were Ashley's.
Okay.
So, I mean, I can talk about 4 if one of you guys want to talk about 5. Because I got the same answers as her for number 4.
Yeah.
I got the same answer for 5, so.
Okay. So for 4, I used the velocity and the distance to solve for acceleration. And actually, the formula that she used is better than how I did it. Because I had to solve for acceleration first and then tried to multiply by mass anyway. But the mass, 950 times velocity squared. So the 25, because you have to convert it into meters per second. So the 25 meters per second squared. And then you divide it by 2 times the distance, which was 120 meters. Got 2,473.96. Yeah, 2,470, because she rounded it to 3 sig figs. The only thing I don't know is why she had it as a negative.
I had it.
It says negative. Yeah, okay. I see why she did that. Okay. So it's a negative force on the car. And then, what's that one below it? Oh, so for part B, you do the same exact thing, except for it says you hit a wall and you stop in a distance of 2 meters. So all you do is change the distance to 2 and then solve for it the same way. You get this negative 148,400 newtons. And that is also what I got when you round it to, she rounded it to 4 sig figs. You guys think it should just be rounded to 3?
Well, that's not the answer. Is it the answer?
Yeah, this one here.
Oh.
Because she had this as
I don't know. It's not the final answer, though.
Oh, I guess it is just that's what it was asking for, wasn't it? So then she just divided them and compared, and then she rounded it to 3 sig figs. So I guess that one doesn't have to be. Yeah, so then she did the 2 different and found what I didn't get. So 104,400 divided by the 2,470 is going to be 60. But that's not the difference between them. It should be the other way. Or I guess that's the ratio.
Yeah, I didn't get B, so I don't know.
That's what I got. I got the same thing she did.
You got 60 newtons?
Yeah.
Okay. Because when I compare them, I would have thought either find like a percentage, or I guess that's the ratio, which is what she did. But I don't know why she put the label newtons on it. Do you know?
Oh, right here?
Yeah, no, down here
On the answer.
on the answer.
Oh. I,
Because I would think it's just a ratio.
yeah, so that has no label.
Okay,
Maybe.
that's okay. That's what I thought. All right, so that's 5. That's 4.
So she did the same thing I did for number 5. Looks like she just took the kinetic, the x, the 2 times mass and gravity, multiplied them and divided them, got 0.459, and then converted it to, wait, what's that? What is she doing there? Oh, okay, I see. And she converted it to meters. So I got the same answer, 0.459. Did you guys get that too, or?
I did, yeah.
Yeah.
Okay.
She did it the same way I did it. So yeah.
Sweet. All right, number 6. I think that was me. All right, so this. What's that mean? I don't remember.
Yeah, I think it was.
All right. So what I did for part A is I took.
Doesn't make it better.
So I took this formula here, and then I inputted the data that they gave us, giving us the values for the. So the 100. It looks weird because of I somehow put them over each other like that. But I got for the height, I got 47.7. Did you guys see the same thing?
Yeah, I did.
And then for the joules lost, I did the thermal energy equals the mass times gravity change in height. So the 750 times the gravity, and then the difference would be 47.7 subtract 2, giving us 189,087.75 joules lost. And then for the
Okay.
work, I used the formula friction, or the friction's direction, times the distance. So I took that 189.87.75 joules equals the 22 over the sine of 2.5, giving us the friction of 374.9 newtons.
So yeah, I got the same answers. My one question is, will he dock if we don't have sig figs on these?
I don't know.
I don't know.
I don't know either.
I don't know that he looks that in-depthly to them.
I think that's probably just on like the Maple TA. I know Maple TA is
The Maple TA is killing me with the stinking sig figs.
I know. I went to the tutoring center for a Maple one of those questions, and I was there for an hour trying to figure it out with one of the tutors. And I was like, well, maybe I just need to enter it differently. So I changed it to a different amount of sig figs, and it works. And I was like, you got to be kidding me.
Of course,
Yeah.
that's awful. I can't stand Maple TA for that exact reason.
Yeah, this homework's painful.
Yeah.
Anyways.
All right, for number 7, for the different types of the energies, I got the beginning. It's just a whole bunch of words, but the main part I think is the mechanical energy is equal to kinetic plus the potential energy. So that's the biggest thing to know.
Sounds good to me.
Yeah.
Who to put?
Good to me. Okay, so I had 8 and 9. Okay, so 8, talking about the dragster, and you want to find out average output in horsepower if it takes 7.3 seconds. So I used the really long equation in the book. All those different equations: the kinetic energy initial, the potential energy initial, the work, non-conservative, all that fun stuff. And so then I basically just whittled it down until to the third line right there, to basically get the change in other energy equals the kinetic energy final minus the work that is non-conservative. Then I just kind of plugged and chugged at that point, and then I I don't know if it was in the book. I might have missed it, but 1 horsepower is the same as 745.7 watts of energy. So then I just converted it to 644 horsepower.
Nice.
Did you guys get the same thing?
I got 644.
Yep.
Awesome. Sweet. Alrighty, and then 9. So 9, I wasn't 100% sure because there's multiple activities for cycling. There's 3 different cycling rows, and they never say at which speed you're cycling. So I just did the 13 to 18 kilometers per hour. So, I don't know.
Oh yeah, that's funny.
Yeah. So as you can see on my paper, so you just take each of the activities, and I converted the watts into kilocalories per minute. And then from there, you just multiply the kilocalorie per minute, multiply that by the time for that activity, and then you add all the chunks together. So I got 3.79 times 10 to the 3 kilocalorie. Does that make sense?
Yep.
Yeah.
I didn't work through that one because I didn't get time to do it, but from what you did, it looks right to me.
Sweet. I'm trying to get it to fit on the page with it, but you know, that's tiny. Oh well.
Cool.
Cool. That looks good.
Good work.
This week I felt like was a little bit easier, though.
Yeah.
It was confusing wording. I feel like that's what always gets us is like the confusing wording.
Mm-hmm.
Yeah.
So this was definitely a better week.
Yeah. Aside from the drowning in the equations, yeah, I feel like I was able to handle it all.
There's a lot.
Yeah.
All right, I'm gonna go into next week's really quick.
There is 9 problems.
Perfect.
Okay.
I'll take some middle problems this time. I feel like I always either do the first ones or the last ones, so I'll take some middle ones this week.
Okay.
I can do 3 this time.
You want to do the first 3?
Yeah, I can do the first 3.
There's some because last week what we did was we looked for the ones that had like 2,
That had similarities to them.
or that had like 2 what's the word? Conceptual problems, and then 1 like with a couple of steps.
Okay.
So I don't know if that's what 1, 2, and 3 are. Just trying to get to it. But
Okay, sorry, I just got it up. Okay, so we have conceptual problem. So 1 and 4 and 5.
So like 4, 5,
conceptual.
and 6. Yeah. So maybe somebody could do 1 and 2, and then Mason, if you want to do 3, 4, and 5.
Okay.
And then I can do 6 and 7, unless I don't know. Yeah, I'll do 6 and 7. So then Landon, I don't know if you want 1 and 2 or 8 and 9. The beginning ones
looking at them.
are normally easier.
1 is really tiny, so maybe we should do like pair 1 and 8, and then 2 and 9.
Yeah, that sounds good.
8 and 9 are huge.
Yeah, so maybe 1 and 8 and 2 and 9.
Yeah, I'll do 2 and 9.
Okay, and we'll give Ashley 1 and 8.
Okay.
I'm gonna write this down so that I don't forget this time.
So I have 2 and 9, and she has 1 and 8.
Okay.
That's fair to me.
Yeah, that sounds great. Mason has
How have you guys been doing on these tests?
terribly.
I feel like they're pretty hard.
Yeah, they are very hard.
It's like I try to write down every single